Okay, usage considerations. Now that we've talked about everything else, structure, functionality, methods, given an example, let's kind of step back and take a look at the big picture. So ConditionObject is very flexible, and that's its virtue. It allows threads to suspend and resume their execution based on shared state, typically as expressed through shared fields, mutable shared fields, shared data. So as we saw before, you can allow one thread to access the critical section while another thread waits. For example, while the queue is empty, another thread can come in and put something into it. And you can basically take turns with multiple threads. I just showed 2 threads here, but you could have n threads that were being used. So it's about coordination. User in Java, with Java condition objects, you can have multiple condition objects. So a user-defined object can have multiple condition objects, which is different from built-in monitor objects, which only have one. What that means effectively is that each condition object that's part of some other bigger object can have separate wait sets, used to wait for different things, wait for not empty, used to wait for not full. However, you've got to be careful. There's some subtleties that make ConditionObject tricky to use in practice. It should almost always be waited on in a loop. So you'll nearly always see it used like this. This is the guarded suspension pattern, where you wait for some condition to be satisfied. Ironically enough, the third programming assignment, part B of the third programming assignment, will actually violate this particular rule, but there's a good reason for it, as we'll see. And the reason for doing this is you typically need to retest the state to see if it's now changed to your liking before proceeding. And if it is not to your liking, you have to go back and wait again for the reasons we talked about before. And the reason why you need to do this is even though you've been signaled doesn't necessarily mean the resource you need is available. And that has to do with the non-determinism of concurrency. Things don't always happen in the expected order, so you have to be prepared for that. This also guards against something called spurious wake-ups, which is a really incredibly esoteric thing that has to do with the design of multi-threaded operating systems on multi-core hardware and multi-processor hardware and so on, where nobody actually signaled something, yet a signal shows up a signal occurs anyway and somebody wakes up. Very weird. So it's kind of like the system is lying to you. That's why we have Pinocchio. You can read about it here. It's very esoteric. And the bottom line is that spurious wake-ups can occur if a thread is awoken from a waiting state, even though nobody signaled it. It's just like spurious. It's like random gamma rays striking your electronics and changing true to false or something like that. It doesn't happen very much, but you have to guard against it. You always use condition objects in conjunction with a lock. We've talked about that several times. We need this to avoid something called the lost wake-up problem. You can go here and read about lost wake-up. So if you didn't use a lock, then some thread could signal one or other waiters. Between the point where signal occurs and the waiting thread calls a wait, if the lock is not held, this will occur in a way where the wake-up will get lost. So use a lock, this won't happen. As we talked about before, a wait will internally release and reacquire its associated lock. That's baked into its semantics. You just have to know that it does that and have faith that it works that way. Another really tricky thing that comes up all the time is, should I use signal or should I use signal all? Now, this is actually a very complex question. As a general rule of thumb, try to use signal if at all possible, because it's much more efficient. It's just going to wake typically one other thread up rather than waking all the threads up, which is what signal all does. And therefore, it avoids the thundering herd problem, because you're just waking one thing up, not everything up. So here's a way to think about this, and we'll talk about it in the context of our array blocking queue. So here are the conditions under which signal can be used. So as you can see here, we're going to have 2 conditions, uniform waiters and one in, one out. So uniform waiters says you can signal something if anybody waiting, or any buddies, because it could be plural, waitings, are all waiting for the same thing. So if you have a condition object that could have one or more threads waiting on it, as long as they're all waiting for the same condition, you can signal, and that'll work just fine. So a good example of this would be the example we just looked at, the example application, where all the threads that are waiting on the not empty condition do the same condition expression check. Is the count equal to 0? So if that's OK, signal works just fine. The other condition is one in and one out. We just want one thing to proceed. So in the case, and that's shown sort of here with when we have put something into the queue, so the queue is no longer empty, we signal one thread, if there is one, to wake up to try to see if it can get anything out of the queue. So that's one in, one out. If both of these conditions hold, then you can use signal. If both these conditions do not hold, then you're probably going to need to use signal all. This is another wacky thing. ConditionObject inherits WaitNotifyAll from Java Object because you can't help it, right? Every Java class inherits from Java Object one way or another, no matter what you do. Do not mix and match these methods. This will become more important in assignment 3B when you're going to be implementing something called the specific notification pattern. And you will be tempted to use wait and notify all if you're doing the version that requires condition objects. Do not fall victim to such temptation, because chaos and insanity will ensue. You should also name the ConditionObject fields to reflect their usage. So, not empty condition, not full condition. This is used to wait until the condition is not empty. This is used to wait until the condition is not full. It's kind of intuitive when I say it that way, but sometimes you're like, what should I call these things? ConditionObject is used in a number of places in Java util concurrent and Java util concurrent locks. However, it's just about never used directly. It's almost always hidden behind other abstractions. So for example, array blocking queue and linked blocking queue use condition objects. That actually should be condition object, not condition variable, and reentrant lock. They actually use these things, but you'll see that you rarely use them by themselves. They're almost always hidden either behind a monitor object abstraction or, in this case, a message passing abstraction. OK, so that's the end of the usage considerations.